Welcome to Intelligence Gateway.
C++ Programming Course, Lecture 05. Module 5 Arrays and Pointers. Arrays and Pointers. Declaring and accessing arrays. Pointers in memory management. Working with dynamic memory allocation. Pointer arithmetic. Common pitfalls and best practices. Arrays and pointers. Arrays and pointers are fundamental concepts in C++ programming that play a crucial role in managing memory. An array is a collection of elements of the same data type that are stored sequentially in memory. Pointers, on the other hand, are variables that store memory addresses and can be used to access and manipulate data in memory. In C++, arrays and pointers are closely related, as arrays are essentially a type of pointer that points to the first element of the array. This makes it easy to access and manipulate array elements using pointer arithmetic, which involves incrementing or decrementing the memory address stored in a pointer variable. Declaring and accessing arrays. In C++, an array is a collection of elements of the same data type stored in contiguous memory locations. To declare an array, you must specify its data type, name, and size. For example, to declare an array of integers with 5 elements, you would write int myArray left bracket 5 right bracket semicolon ... To access individual elements of an array, you can use array indexes. Array indexes start at 0, so the first element of an array is accessed using index 0. You would write int myArray left bracket 5 right bracket semicolon ... To access individual elements of an array, you can use array indexes. Array indexes start at 0, so the first element of an array is accessed using index 0. For example, to access the third element of an array, called myArray, you would write int x equals myArray2. You can also use loops to iterate over all the elements of an array. This is useful when you need to perform the same operation on each element of an array. Pointers in memory management. Pointers are a fundamental concept in C++ and play a crucial role in memory management. They allow us to manipulate and access memory locations directly, which can be very useful for optimizing program performance. However, working with pointers can also be tricky and requires careful attention to avoid common pitfalls like null pointer dereference or memory leaks. It is important to understand how pointers work and how they interact with the memory allocation system in order to use them effectively. Working with dynamic memory allocation. Dynamic memory allocation is a powerful feature in C++ that allows programs to allocate and deallocate memory at runtime. Unlike static memory allocation, which is done at compile time, dynamic memory allocation gives programs the flexibility to allocate memory as needed during program execution. Pointer arithmetic. Pointer arithmetic is a powerful tool in C++ that allows you to manipulate memory locations by adding or subtracting integer values from pointers. For example, if you have a pointer to an array, you can use pointer arithmetic to access individual elements of the array. By adding an integer value to the pointer, you can move to the next element in the array. Similarly, by subtracting an integer value, you can move to the previous element. Common pitfalls and best practices. One of the most common pitfalls when working with arrays and pointers in C++ is accessing memory locations that have not been properly allocated. This can lead to unexpected behavior and even crashes. To avoid this, always make sure to allocate memory before accessing it and remember to deallocate it when you are done. Another common mistake is using invalid pointer values, such as null or uninitialized pointers. Always initialize your pointers to a valid memory location or set them to null if they are not currently pointing to anything. Additionally, be careful when dereferencing pointers, as accessing an invalid memory location can also cause crashes or other errors.
Thanks for watching. For more information, like, comment, and subscribe our channel.